Hi, so this is the second video. Obviously, you've gotten the first one. So we're going to talk about multiplying probabilities and the probability of and. When you finish this video, you're going to do a worksheet. It's up to you if you want to take notes or not. I am going to talk about this, and we briefly talked about it this last class, but I think it's also really good practice to take notes without me talking and you kind of just figuring out what it is that's important to write. So feel free to ask the substitute to stop at any point, even if it's just you, to say, can you hold on so I can write this down? That being said, multiplying probabilities, the probability of A and B, if the events are independent, may be found by multiplying the individual probabilities. What I really like is this if they are independent. And I think that this is important to write down. Two events are independent if the outcome of one event does not change the probability of the second event occurring. And I like this example. If a student tosses a 6-sided die and gets a 3, and then retosses it and gets a 5, the two events have no influence over each other in any way. So they are independent. And I think that's a great reminder. If they can't influence each other, then they're independent events. Okay? If I roll the die and I get a 3, the next time every single one has an equally likely outcome of happening. So if I was to find out the probability of rolling a 3 and then rolling a 5, it'd be 1/6 times 1/6. So there's a 1 out of 36 chance of rolling both of those, one after another. Independent events or situations. The multiplication rule can be used to find the probability of 2 or more events that occur one after another. That's probably important. For example, if a coin is tossed and then die is rolled, you can find the probability of getting a tails on the coin and a 4 on the die. Those two have nothing in common with each other. These two events are said to be independent since the outcome of the first event, tossing a coin, does not affect the probability of the second. Some other examples of independent events. I like to write these down because then I have no reason to think later on, is this independent? Is it not? Should I multiply? Should I add? You can just go back to that. I would have titled my notes to begin with too as independent events. So one is rolling a 6 on a die and then rolling a 3 on the second or the same die. Okay, that's a 1 out of 36 chance. Drawing a queen from a deck of cards, replacing it and shuffling it, and then drawing another queen. I would make sure that you underline this replacing it, because that's important. If you didn't replace it, then the events are not independent, correct? Because the second one has a different chance of the other. They're affected by each other. So that word replacing it is important, okay? Multiplication rule, when two events are independent and the probability of both is occurring, you multiply. So example, find the probability of tossing a tails on a coin and then rolling a 4. So probability of tails is 1/2, and then rolling a 4 is 1/6. So verification, you can see that this actually is true. Remember, it's 1/2 times rolling a 4 is 1/6. So that's 1/12. And if you actually listed out all the options, you would notice that tails and 4s only happens 1 out of the 12 times. Because 1/2 times 1/6 is 1/12. Another great one, 74% of voters voted for the school bond and 28% voted for the gas tax. What is the probability a person voted for both the school bond and the gas tax? Well, I would just take both of my probabilities and multiply them, making sure to change them into decimals. For instance, 74 would be 0.74 and 28 would be 0.28. So the chance of you voting for both the school bond and the gas tax is 0.207, so that's 0.21 or 21%. Okay, these are some great examples right here. It would be probably helpful if you work on these right here. Find the probability of rolling a 2 on a 6-sided die and then rolling an even number on the same one. So 2 and even. I'm going to give you a moment to think about that. Okay, so the probability of 2 is 1/6. Probability of even, well, it's 2, 4, 6. So that's 3 out of 6. So that's 1/2. So then that would be 1/6 times 1/2 would be 1/12. Next, the Harris poll found that 46% of Americans say they suffer great stress at least once a week. What is the probability that 3 randomly selected people all say they suffer great stress at least once a week. So great stress and great stress and great stress. So it's 0.46 times 0.46 times 0.46, which is the same as saying 0.46 to the what power? Third. That's 0.097, which rounds up, if you make that it's 0.9, all right, if you make that into a decimal, it is 9.7%. If 2 people are randomly selected, find the probability that they both have the same birthday, same month, and same day. Well, it's pretty random that they would have that, right? Same month and same day. How many days a year? Let's pretend we are not in leap year. So 1 out of 3, same month is 1 out of 12, and same day, 1 out of 365. Okay, let's move on. I think we've got enough examples right here. Let's talk about without replacement. And it's not going to change it too much, but what's going to change if you don't replace it? Your denominator. If a sequence of events occurs without replacement, then the denominator in each probability will decrease by 1. Find the probability that you will draw a heart and then a diamond without replacing the first card. So if you have 1 heart out of 52 cards, okay, that's 13 out of 52. And if you don't replace that, then it's 1 diamond out of 51 cards. So then that's 13 out of 51. So remember I said earlier that it's a little bit different when you don't have replacement, and to underline that. And there's still, like, I wouldn't necessarily qualify this as something or another, but what I would remind myself is that that word replacement's really important. Okay? So if you do 13 out of 52 times 13 divided by 51, the probability is 0.064, so 6.4%. Okay, there's another one with marbles. I want you to look up here and try this on your own. A bowl contains 3 red marbles, 2 blue and 5 white. A marble is pulled, and then another is pulled without replacement at random. I want you to find this probability of a red marble and then a blue marble, and find the probability of at least one of them is white, which is the same as a white and a white marble. Okay? Why don't you wait on B, but why don't you try A with your neighbor? So the first thing I would do is find out what my denominator is before even pulling anything. So 3 plus 2 is 5, plus 5 is 10. So a red marble would be 3 out of 10. So 3 divided by 10, right? Probability of red. Now, if I pull that out, it stays out. Now I don't have 10 marbles. I have 9. And so then it would be 2 out of 9. So you should have gotten 0.6 repeating, which is the same as 2/3. At this point, I would like you to work with your neighbor on the homework for multiplying probabilities, the probability of and. Okay? You will be working on this for about 15-20 minutes. There's a front and a back. And if you finish early, check your answers with your neighbor, and then we'll watch the other video.